session number 4 of SHM. And today we are going to see how to exactly add SHMs in 1 dimension and 2 dimension, and it's going to lay the foundation for interference of waves in light, sound and waves on a string, where we are going to see constructive, destructive kind of interference. And to understand that very clearly, you should understand how SHMs are added together. Without that, you will not be able to solve those kind of problems. And I have just kept a lecture dedicated for superposition of SHMs today. And welcome, this is Shreyas here, your master teacher for physics at Vedantu going live. And if you are new to this channel, let me quickly introduce myself. I have been a physics master teacher in Vedantu for quite some time, and before that I have been teaching in many offline coaching institutes. And when I have taught many students, in fact thousands of students I have taught, I have made sure that even if they do not qualify for IIT, they have got into a good college. And many of my students are right now in IITs, NITs, BITS, you name it, and some of them have even got 2-digit All India ranks. And I really hope that you too make me proud one day by getting really great ranks in the upcoming examinations. So welcome. I know there are different kinds of students out here. Some of them could be droppers, some of them could be 10th, some of them could be 11th, some of them could be 12th standard. This is a very important chapter and it carries a lot of weightage in JEE Mains, Advanced, BITSAT and you name it, all the other examinations. So get ready, and these sessions are definitely going to be helpful for the preparation of KVPY examination as well. Also, if you want to get in touch with me, you know what you can do? You can also get in touch with me on my social media handle, and that is Shreyas_Vedantu. That's on Instagram. You can follow me out there, where I keep posting a lot of videos, updates and about my daily life. So hello Kashyap, Ankit, Kirito, Thanmay, Ankit, Dinesh, VK, Akshat, Manoj, Asmi, 17S, Aishwarya, Shubhash, Yalini, and so many others out here. Hello Karthik, hello Simran, welcome, welcome, welcome. Hi Janvi. So before I forget, you know what else you need to do? You need to go ahead and hit the subscribe button if you are new to this channel. This subscription is absolutely free of cost. If you are preparing for any of the upcoming entrance tests, doesn't matter which entrance test you are preparing, be it BITSAT, be it CET, be it for JEE Mains or JEE Advanced, doesn't matter. Go ahead, hit the subscribe button, because only when you hit the subscribe button, you will get all our regular updates, notifications, important news and all the lectures that we conduct out here. And if you've already done that, guys, I'm going to get all the energy required to conduct this session only by simple like out there. So go ahead, smash that like button, because that is really going to encourage me to conduct more such sessions. And thank you for all those of you who have been constantly supporting us, loving us, liking us, sharing our videos, commenting on our videos. Thank you very much. Welcome Anish, hello Abhishek, hello Priyanka, hello Rishabh. A lot of new people out here too as well. Hello Devi, hi Sneha, welcome, welcome, welcome. Yes Manoj, if you have the right spirit in your mind and dedication and that hard work is there, then yes, it can be enough. All right. Okay, I am very good, Tanmay. I hope you are good, and get your friends also along, Tanmay. All right. So let's begin our session, and let me also quickly tell you about this week's timetable. So we did a KVPY session yesterday and another KVPY SX session on Saturday. SHM, we are going to continue and finish it by tomorrow. Tomorrow it's going to be damped and forced oscillation. We're going to start with EMI on Thursday, and it's going to be a big session on Friday. It's a marathon session with advanced level problem solving as well on Friday. That's a big lecture. And on Saturday morning, 8 o'clock in the morning, you are going to have physics Menti quiz, and Sunday in the night you're going to have the chemistry Menti quiz. All right, so that's something you should keep in mind. So let's quickly review or revise, the phasor diagrams, what is phase, etc., in case you have missed it, and then we'll quickly see how they are related to addition of SHMs. So this is going to be a very short, quick lecture. Do not worry, and let's get going, guys. Come on, keep making all your notes out there. And remember, make friends out here if you are new to this channel, because we are a lovely family of JEE enthusiasts. We call ourselves the minions. So minions, come on, greet your fellow new minions out there as well. And the new minions, please introduce yourself to the other minions out here on this channel. All right, so let's get going, guys. So what is Phasor diagram? So Phasor diagram is nothing but a conceptual diagram which helps us solve problems. Every particle which undergoes SHM, there is always a phasor diagram that you can draw. Basically, it's nothing but any particle which goes in a circular motion, the projection, the shadow of it performs SHM. So if one particle is doing circular motion, the shadow below performs SHM, and this circular motion represents that phasor diagram, is what I have told you before. So if I have a circle and I have a reference line, okay, this is my reference line, this is my horizontal axis, all right. I imagine a particle which is going in a circular path. Initially the particle is over here, and this is the angle which it makes with our reference line. Then on the horizontal axis, okay, where my particle is going to execute, the shadow of this is going to represent the initial position of that particle. So in the circular motion, the particle is over here. This is some length which is going to revolve like this with constant speed at time 0. That is, initially the shadow of this line is this much, and that represents, you know, the initial position, which is going to be a sine phi. With the passing of time, this point, understand, so phi is initial angular position in circular motion, but it is initial phase angle for SHM. Remember that. Okay, so very, very important. So you can see that all of them are related to each other. Yes, Anand, you can definitely crack it. Definitely. Yes, Kirito, light should be kept exactly above it. That's the meaning of the projection on a horizontal line. Correct. So if you are taking projection on a horizontal line, light ray should be exactly vertical. It cannot spread like that. Correct. Don't worry, Anand. Just keep attending all the lectures. Hello, Kushbu, join in. All right. Good evening, Jitesh. Yes. So here is the thing. Next, the radius of this circle is the amplitude of the SHM, but for the circle, it is nothing but the radius. So radius is A, but it is also the amplitude of the SHM. And after some time, what happens is that particle moves by some angle, and that angle will be omega into t. I have just told you about it in one of my previous sessions. So it's just quick revision, guys. And then the new projection will be somewhere else. Instead of being here, it is somewhere else. And that value comes out to be a sine omega t plus phi, which tells you that it is a SHM. So the projection of circular motion is nothing but a simple harmonic motion. Here omega is angular speed for circular motion, but for SHM it is going to denote angular frequency. Understand that. And similarly, omega t plus phi, this total angle is called as the phase angle, but in circular motion it is the total angular position of that particle. So understand, omega t plus phi is the angular position of that particle, but in SHM it is nothing but just called as the phase of the SHM. So whenever you think of SHM, you can always visualize that there will be a circular motion, hypothetical, imaginary circular motion, which represents that SHM. Alright, these are the similarities between circular motion and SHM. And then we also discussed about something called as the phase difference. I hope you remember this. No problem, even if you are late, guys, join in, Science Priya, no problem, join in. Kushbu, Shreya, hello, join in. Yes, so we have also seen what is phase difference. So imagine there are two SHMs. So naturally there will be two phasors. So this is the phasor 1 of SHM 1, whose projection falls over here. Phi 1 is the initial angle of the first SHM. The second SHM is somewhere here. It's making a different angle. I call it phi 2 initially. So their projection will be somewhere here. So you will see both these particles will not be moving simultaneously, but there will be some lag, or one will be ahead of the other. So like over here, you can see each one will follow the next. All right, like this. As these 2 points revolve in this circle like this, you will see these two projections, these two perpendiculars, these two lines will keep shifting like this. You can visualize this in your head. So phi 1 minus phi 2, whichever is bigger comes first. So I have put a modular symbol there. It's called as the phase difference between two SHMs. That's what I have told you. And if this phase angle, phase difference is 0, they are said to be in phase. And if delta phi is 180, this is said to be out of phase. Is this clear? Is this clear? Yes, angular speed in UCM and angular frequency in SHM are equal, Dinesh. Yes. Yes, correct, correct. I hope everybody remembers all of this. Yes. If you remember all of this, come on, go smash the like button and say yo in the chat box. Come on. Yes, Pankaj, definitely. Why do you think we started these series? We started this series for 11th and 12th because, you know, a lot of students have a lot of backlogs and they want to revise. So that's why we started this series, because we can complete all these things, all the portions in the next 1 month before your board examinations, before your first attempt of JEE, everything. So please watch all the videos because they are meant to cover everything in detail but in a crisp, short manner. That's what we intend to do. But it is not so short that we exclude all the details. So we have covered a lot of things in these lectures, and plus there will be a lot of advanced solving problem sessions very soon, and previous year question papers, Menti quizzes, so many things are coming up. In fact, we have already started with KVPY series, and sometimes we are also going to conduct these PYQ series and all that. Don't worry. All right. Okay. So now let's talk about the important aspect of today's class. What is the meaning of adding of two SHMs? What does it exactly mean when I say I want to superimpose two SHMs? Superimposition, adding, all these words are very similar, guys. So let me create a very nice example, beautiful example. So let's get in Pandu out here. So we have Pandu. So you can just welcome Pandu by saying hello on the chat box. And any other message you would love to have for Pandu. Let's also get in Champa. But let's see what these guys are doing out here. Now this Pandu is going back and forth. He's going to go back and forth. Dev Krishnan, maybe you should watch the first few lectures of SHM. Maybe then this lecture will make a lot of more sense to you, because this is the 4th session. All right. So if you already have some idea about SHM, then you can continue watching. All right. Okay. So basically, Pandu is performing SHM. He's going to go back and forth, and this is the equation of Pandu. XP is position of Pandu, AP is amplitude of Pandu, omega is the angular frequency. So omega will decide how quickly he's going back and forth. It will decide the frequency and the time period, and amplitude will decide how far he goes on left and right side. Okay, so this is the equation of Pandu. Now he holds a plank, and on that is Champa, and Champa is going back and forth with respect to Pandu. That's why these symbols, you can welcome Champa as well. So XCP, Champa's position with respect to Pandu, is ACP, amplitude of Champa on the plank, sine omega t plus phi. I'll explain this equation, why that extra phi has come. The reason why that phi has been mentioned is because maybe they do not have the same phase. Maybe they do not go towards the extreme position simultaneously. Maybe there is some lag. Maybe when Pandu is moving towards the right, Champa could be moving towards the left. Maybe when Pandu is moving and has reached the extreme, maybe Champa has just reached the mean position and still stays moving. So there can be some phase difference between them. I hope this is clear. Yes. So Pandu is holding that plank. That plank will also go left and right. And on that, Champa is going to go left and right with respect to the plank. Now guys, think about it. Both of their omegas are same, and we are going to only study similar omegas in JEE. We do not have omega 1 and omega 2 for JEE. Remember that. So whenever you add SHMs, you always are going to have the SHMs of the same omega. Different omegas do not come under the JEE syllabus, so keep that in mind. Now, if I ask you what is exactly Champa's motion from the ground frame of reference, Champa's motion with respect to Pandu is known, Pandu's motion with respect to ground is known. Use the concept of relative motion and you know what to do. Champa's motion relative to Pandu plus Pandu's motion relative to ground, if I add them, I will get the total motion of Champa with respect to the ground frame. Do you agree with this or disagree? Come on. I hope you guys get it. This is the concept of relative motion. In fact, if you shift xp on the left hand side, you will get xcp is xc minus xp. That is the definition of relative motion. x12 is x1 minus x2. I hope you guys got it. Agreed? Everyone understanding it? So now, do you understand what is the meaning of superposition of SHM? This is one SHM, Pandu is one SHM, Champa is second SHM. So when I superimpose both of them, I get a new motion of Champa with respect to a different frame. That is basically the resultant of the addition of these two SHMs. So the addition of these two SHMs has given me Champa's motion. I hope this is clear. That's the meaning of addition or superimposing of SHMs. Very, very important. Very good, very good, very good people, very good minions, very good, excellent minions. Let's now see the mathematical meaning of this. Let's see the mathematical meaning. Now, I'll give you two simple equations just to explain it, and then I will tell you how to solve them. Just imagine I ask you to add these two equations. 3 sine 2 pi t plus 4 sine 2 pi t plus pi by 2. You'll be like, sir, I know what to do. I can expand this, or I can use sine theta plus pi by 2 formula and I can get it. Yes, very good, you can do that. But there is also another way. And today I'm going to teach you how to add these kind of equations, or even equations like this, when this might not be pi by 2, something else. 10 sine 4 pi t plus something plus 8 sine 4 pi t plus something else. How do you figure out what is the final answer? We are going to see a way. And believe me, it's very simple. Without expanding any of these, you can directly write the answer. Are you guys interested now? I can directly write the answer with a simple formula, which I'm going to teach you now. There can be more than 2 terms over here. There can be 5 terms over here. Something else, sine 4 pi t plus something else. Even then you can add them with one simple formula, and that's what you're going to see. All right. So let's see what we are going to do. And no, it's not quantum mechanics, guys. Chill. Okay. Now, this is where the knowledge of phasor diagrams will help you. Let's see how do we do that. Okay. Now, we just talked about phasor diagrams. In case you're a little bit late, when I just revised phasor diagram, you can just quickly go back and just try to recollect it. Even in the live session, you can quickly go back and come remember that. And don't worry even if you're late. I hope you have some idea about phasor diagrams, which I just revised. So this is the phasor diagram of SHM number 1. This radius is the amplitude. This line, right? This line is the radius, that is the amplitude of the SHM. At any time t, the angle made with the reference line will be omega t plus phi 1. Phi 1 was the initial angle, plus omega t will be the further displacement, so total angle. That projection, a sine of that, will be the SHM. This horizontal line is the SHM's equation. Great. This is one equation. I want to add this phasor with another phasor. This has some another phi 2, another amplitude, another phi, but same omega. Notice, what did I just tell you? In JEE, you have only same omegas for addition or subtraction. So that's very important. I'm very good, Ali. Join in. Now, what we'll do, we'll play a very simple trick, guys. Pay attention. I'm going to shift this phasor diagram because I want this plus this, right? I want this number plus this number, the bottom one, which I have written over here. I want to know what is the addition of just this and this. So to do that, I will take this phasor, move it and place it over here, something like this. So I have this diagram as it is. I will take that diagram and put it over here so that the center of the second phasor is exactly where the first phasor ends, like this. Now I know it looks quite complicated, so let's get rid of the unwanted parts out here. So let's get rid of the circles. I hope you are understanding what I have done is just shifted that circle. Let's still remove some more things which are not needed for us. Now it looks a little bit neat. And you can see the red one is the phasor of first SHM. This blue one is the phasor of the second SHM. Their projections are also shown in the horizontal line, and the length of each one is also mentioned over here. This length is here, this length is here. Each one of them is A1 and A2, the slanting ones. What do I want? I want to just add both of them. I want this plus this, right? So you know what is the trick I'm going to do? This now looks to me like something like vectors. Yes, like vectors. So just imagine, this is vector 1, this is vector 2. I make the resultant. Now, I take the component of that resultant. In the horizontal direction. Guys, listen to my statement carefully. Listen to my statement very carefully and think about it. Addition of components of two vectors will be the same as the resultant of the component or the component of that resultant. Think about it. I'll repeat. Addition of components of those two vectors is the same as first finding the resultant and then taking the component. Isn't it the same thing? Do you agree? Do you understand it? No, it's not yet constructive, Mehak. It's not yet. It will be used, Ali, in YDSA. These concepts are used over there. I hope this is clear. Did you guys understand it? Did you understand it? Everyone, have you got it right now? Let me know in the chat box, guys. If you guys got it, say yo, yes. Come on, let me know, minions. Did you guys understand it? The addition of components of two vectors, red and blue, is the same as first finding the resultant and then finding the component, which is that black one. That's it. That's what it is. Very good. Very good. So now, that's the whole concept. So whenever you want to add two or more numbers, that's it, guys. So let's go back. So remember, I wanted to add, where is it? These two things. So it's very simple. Just treat them like vectors. If you treat them like vectors, it's very simple. Now please understand what each one of them is. This is amplitude 1. This is amplitude 2. This 2 pi is omega. This 2 pi is also omega. Here phi 1 is 0 and phi 2 is pi by 2. Now just think about two vectors, guys. How? One vector of amplitude A1, which is of magnitude 3, like this. Another vector of magnitude 4, but making angle 90 degrees with the reference line. So like this way. So this is of magnitude 4, making angle 90 degrees with the reference line. Just figure out what the resultant is. The resultant will be here, correct? The resultant will be here. How much will be this angle? How much will be this length? Sorry. This length will be how much, guys? 5. Do you guys get it? This length will be 5, correct? Everybody understood this? Now also think what the angle will be. This angle will be 53 degrees. This is a standard triangle. 3, 4, 5. So guys, the final answer is, I'll tell you, just put 5 sine and then 2 pi t but plus 53 degrees. You can convert it into radians later on. That's it. That's the final answer. That's the final answer. Just do the vector addition. So the number which comes over here, this number, which is the final amplitude, is the resultant of A1 and A2, but not direct addition, not 3 plus 4. It is 3 bar plus 4 bar. So they have directional information in it. That's what you need to do. That's all. And this angle can be found by vector diagram. That's it. Why not 37? Because you have to measure everything from the reference line. Remember, our reference line was vertical. So everything from the reference line, that's why 53 degrees. I hope that is clear. Shreyas, well, you can solve it by expansion, but that will be lengthy. That method of using vector addition is the simplest method and the best method to solve these problems. That's why I'm teaching you. Okay, Shreyas? Okay, very good. So similarly, this also can be solved, but I'll just tell you what will be there in this question, guys. Come on, think about it. 10 will be one vector making angle pi by 3. Pi by 3 means 60 degrees. So draw a vector of length, 10, but understand this angle over here, this angle will be 60 degrees. Okay, then draw another vector of magnitude 8 but making angle 30 degrees. So this will be like this. This will be having magnitude 8 and this angle over here will be 30 degrees. So the resultant will be something like this. This will be the resultant. I hope this is clear. This A will be the resultant. Is that fine? Everybody understanding this? Everybody understanding this? Yeah, that's it. As simple as that. So any other method will be very complicated. Yes. Okay. So now let's draw the final conclusion for this. The final conclusion for this is that, so let me go back. Yes. Okay. Here is the thing. Please write it down, write it in your notes. When two or more SHMs of same omega but same omega, and they can have and amplitudes A1, A2, AN and phase constants phi1, phi2, phi n are superimposed, then their resultant, okay, very important statements coming up over here, is also a SHM of same omega. Remember that omega was the same because all those vectors will rotate simultaneously, and amplitude phase constant is found by what? Vector addition of phasors. Vector addition of the phasors. And hence I will say a vector is A1 vector plus A2 vector plus AN vector. These A's are the amplitudes, but when I put a bar, they represent the phasor of it. So that is what is very important. I hope this is clear. I hope this is clear. So angle, Saurabh, you can again use geometry or any method that you have learnt in vectors. Either you can use that formula tan alpha is b sine theta upon a plus b cos theta, or you can use vector resolution I, j, k components. Alright, so you can use, or you can just use simple geometry, sine rule, cosine rule, whichever rule you want to use, and you can figure it out. Yes. Bhargav, all the notes will be mentioned in the description box below. You can check out the link after some time. Okay, great. So I hope you have written it down. Get ready for some questions coming up on your screen. Remember, all those vector addition formulas, a square is a1 square plus a2 square plus 2a1 a2 cos theta is valid. Even that formula tan alpha is b sine alpha theta upon a plus b cos theta, that is also valid for these kind of problems. Remember that. Okay, so Bhargav, please check out the timetable. I have just mentioned it at the start of the lecture. Alright, so let's concentrate on the lecture now. So here is the first question. If two SHMs of different amplitudes are added together, the resultant SHM will be maximum if the phase difference between them is dash, and minimum if the phase difference between them is dash. Come on guys, think. Yes, Rohit, this chapter is very important. Come on. SHM has almost similar weightage as rotation. Rohit, all the lecture schedule is there in the PDF. Weekly schedule is there. I mention it in the PDF, so please check out the PDF at the bottom. Alright, in the first few pages we mention the timetable. So guys, please check the timetable. It's there. The weekly schedule is there, and I also announce it at the start of the lecture. Come on. Okay. Chalo. That's why it has a lot of weightage. Yes. So the resultant will be maximum for what angle? Think about it, guys. It's just like vectors. When will two vectors A and B give maximum resultant? this will be max resultant. That's when the angle theta between A and B is 0 degrees. Look at that, A and B are parallel, so the angle is 0 degrees. And when will it be minimum? When vector A and vector B are opposite to each other, that's when the resultant is minimum. And angle between A and B is obviously 180 degrees. So be careful about it. Okay, I hope this is clear. I hope this is clear. Yes. So let's get going to the next question. Very simple. Use the knowledge of vectors. Whatever knowledge you have in vectors, use it directly over here. Whichever method you want to use, it's up to you. Now, if you want to start solving this question on your own, go ahead. I'll be doing it for all other people out here who want me to solve. Okay, so don't worry. Either way is fine, guys. But just listen in. 3 simple harmonic motions, 3 SHMs of amplitudes A, equal time periods in the same direction are added. Then the phase of the second motion is 60 degrees of the first, and the phase of the third is 60 degrees ahead of the second. Find the amplitude of the resultant. So guys, just treat them like vectors. You will never face any problem. There are 3 SHMs. Amplitudes are A and time periods are equal. The moment time period is equal, omega is also same, because omega is 2 pi by t. So guys, think about it. If this is SHM1 phasor of amplitude A, the second SHM is 60 degrees ahead. So 60 degrees ahead means somewhere over here, this is second SHM making angle 60 degrees again of amplitude A, and the third SHM is 60 degrees ahead of the second. Okay, it's more 60 degrees over here. This is also 60 degrees. All of them are A's only. So the question is, find out the amplitude of the resultant motion. Guys, all you need to do is do vector addition. Just do vector addition. This is SHM1, this is SHM2, this is SHM3. Guys, I feel we can add 1 and 3 first. Let's add 1 and 3 first. So what will be the resultant of 1 and 3? Think about it. What will be the resultant of 1 and 3? Use the formula. First, let's solve 1 and 3 and then let's add it to 2. Guys, the resultant of 1 and 3 will be A1 square, which is A square, plus A3 square, which is also A square, plus 2A1 A3 into cos. Angle between them is 120 degrees. Isn't it? It's 120 degrees. So what will it become? It will become 2A square minus 2A square. Cos of 120, guys, it's minus half. Correct? It's minus half. So understand this. What will oh sorry, this was plus, my bad. So plus 2A square with that minus sign will become minus A square. So 2A square minus A square will just become A. I hope this is clear. I hope this is clear. Now think about it. 1 and 3 are already taken care of. So the only thing which is remaining is 2. The resultant of 1 and 3 was also A. So what will be the direction? Come on, by symmetry, the resultant of 1 and 3 should lie on the angle bisector. Correct? The resultant of 1 and 3. So it will be in the same line as of 2. Think about it. This is also A and this we just figured out to be A. Did you see that? Did you see that? I hope you guys got it. So resultant of 1 and 3 by symmetry will lie on the angle bisector, and that added with the 2 will give me a total resultant of how much? 2A. So that should be the answer. Yes, Mr. Best, you are a little bit late, but don't worry, I'm going to start a fresh topic after this. Adding of SHMs in 2D, so don't worry, you can always watch the replay of the first part. All right. So the correct answer is 2A. What a brilliant question. Let's get going to the next question. I hope you are getting the hang of it. These are not very difficult questions and many of you have also answered before me. Come on, let's see how many of you answered this question before me. I'm going to explain it slowly for all the students out here who still don't have confidence. No problem, you have come here to learn and I'm going to help you out. Shreyas Sir is there for you guys, don't worry. All right. So, Ragunesh, I'm not sure of NDA and all that, yeah. I generally teach for JEE Mains, Advanced, BITSAT, CETs, need and all that. So I'm not sure of ND examinations. I don't want to give wrong information. That's the thing. Okay, so you have to add 4 SHMs. So think about it. How are we going to add it? It's very simple. Just think about the phasors. This first SHM has an amplitude of 1, phase constant 0. Look at that. Amplitude is 1, phase constant is 0. So if you have to draw the vector or the phasor, basically, its magnitude will be 1 and it will be pointing towards the north because phase angle is 0. We always measure everything with respect to vertical y-axis. Okay. X2 has amplitude also as 1 but phase constant as pi by 2. So pi by 2 is there and magnitude is still 1. Okay, so this magnitude is also 1. Great. X3 is magnitude 4 and phase constant pi. Pi means 180 degrees. So 180 degrees is below, magnitude is 4. So this is having magnitude 4 and this is vector number 3. And lastly, this is having magnitude 3 but angle is 270 degrees. So it will be somewhere over here, guys. This is having magnitude 3 and this is my vector number 4. So you just have to find the resultant of all of them. Take care of them individually, guys. It's very simple. First, take care of the y-axis. 4 below, 1 on the top. So resultant will be how much? It will be 3 below. 4 below, 1 on the top. So resultant 3 remaining. Here 3 this side and 1 that side. So resultant 2 over here. So 3 and 2 are remaining in perpendicular directions. Obviously now you can figure out what the resultant is. So guys, come on, what the resultant will be. And they are at 90 degrees. Come on, use Pythagoras. Yes. Come on guys, come on guys. Come on VK channel, focus. Don't talk about food and all that now. Come on, focus. When we talk about food, we'll talk about food. But right now, focus. Come on. Yes, Daniel, but you also need previous year's questions. I think I have already answered you about that thing. Yes, root 13. Everybody got it? Root of 2 square plus 3 square, which is nothing but root of 13. That's the answer. Correcto. Excelente. Yalni, Krito. Very good. Excellent, guys. So now, are you confident about SHMs in 1D, adding SHMs in 1D? Everyone, if you're confident, come on, go hit the like button out there and also say yes in the chat box. Come on. And if you're new to this, please do not forget to hit the subscribe button. So, yes, Bhargav, little bit. You need circular motion. A bit, yes. Now, I'm going to teach you how to add SHMs in 2D. A lot of you might be confused how to do this. Don't worry, I'm going to help you out and it's very simple. Observe, and by the way, I'm going to show you some really cool animations at the end of the class, so stay tuned. Really cool animations. I'm going to show it right in front over here to make you visualize, so stay tuned guys, come on. So before that, let me also tell you that for all the people who still want to get into the pro subscription, the offer is still valid. Understand this pro subscription, it's not for 11th or for 12th, it's for everyone. Be it JEE, be it NEET, doesn't matter. And if you take this subscription and let's say for 12 months or something like that, this is continued from 11th to 12th. So if you are having some doubts or queries on this, do not hesitate to ask me on Instagram or in the comment section below after the video ends, not in the live chat. I'll definitely help you out with all the queries that you have. But this pro subscription includes all the micro courses, test series, assignments, the Tattva module from Vedantu, and live doubts after the class, option to learn in English, Hindi, as well as, all the regular batches, plus preparation for KVPY next year, this year, and also, you will have courses for boards, etc. You name it, you don't have to go anywhere, you name it, all those courses are present in Vedantu. And the prices are also very reasonable. So you can check out all the prices after the discount of 20%. Like say for example, for 12th standard, for 3 months it is 21,000. After discount it comes to 16,800. So these prices are very reasonable. Like you can see this for 11th standard, and similarly for dropper students out here. If you see the per day cost, it's hardly anything, guys. Very few institutes in fact offer these kind of prices and these kind of facilities for all of you, where you get a holistic approach, and it's not just for a particular course, but it's numerous courses. And once you are in this subscription, just like Netflix, no matter how many movies you watch, it's all free. So same way, once you are in the subscription, no matter what you watch, it's for free of cost. Remember that, and check out the description box below, and you can avail the 20% off right away by using the coupon code SHHPRO, which is very fascinating, guys. Come on, I mean, you're getting 20% off out here and so many things at a very good rate. So definitely please give it a thought after the lecture. Okay, have that link opened after that. All right, so why is the color changing after I touch the screen? That's because wherever I touch, right, so I think that special icon comes over there, so that's why probably it looks like that. Okay, I hope, Sneha, that probably answers your question. Okay, and or is it the complete color which is changing? I'm not sure. Let's see. At least for me, nothing is changing the moment I change the slide. If I change the slide, I mean, it's still appearing same. Maybe because of the camera, or there is some lag out there. That's why the color appears different. Okay, so let's try and add SHMs in 2D, guys, in perpendicular direction. So very, very important. We don't have 3D. Don't worry. Okay, so are you guys now ready to add SHMs in 2D? Let me know. Come on, let me know, minions. Come on, come on, come on, come on. Let me know in the chat box. Everyone ready? Yes? No? Come on. Yes? Very good. Very good, Priyanka, Science Priya, Yalini. Yes. All right, sailors. The captain is going to make you sail through these rough seas now very easily. Observe. Guys, these kind of visualizations nobody will give you. I'm telling you. Imagine a lift which can travel up or down in the y-axis. Okay, imagine a lift which can travel up and down. Imagine a pandu who can run left and right. Now, just imagine that, pandu is performing simple harmonic motion in the x-axis. He's going back and forth like this. Left and right. Left and right. He's going back and forth. He's performing SHM in x-axis. Similarly, imagine the lift is going up and down, up and down. It's performing SHM in the y-axis. Now, if both the motions are superimposed, think about it. Pandu is not only going to go left and right, but also going to go up and down. So you can see the displacement is not just horizontal, but also there is a vertical component because of the lift's motion. So the resultant motion of Pandu is called as the superimposed motion of two or more SHMs in 2D. So there are two SHMs, one of the lift up and down, second of the Pandu right and left, and they are superimposed to see the resultant motion of Pandu, how it looks like. All right, Jana, very good, and I can't speak Tamil. Okay, very good. So let's just talk about these equations, guys. Let's just imagine Pandu's equation is AP sine omega t. So Pandu's motion, AP is the amplitude of Pandu's SHM, omega is the angular frequency of Pandu's SHM. Similarly, the lift goes up and down, so this is the y coordinate of the lift, Al is the amplitude of the lift, omega is the angular frequency, phi is the phase difference between them. Here the phase is 0, here the phase is phi, so the phase difference is basically just phi between the lift and the Pandu. So how will the resultant motion look like? So the resultant will be, this is the position vector r bar, is the x coordinate will be xp I cap, the y coordinate will be yl j cap. The best part is Pandu's motion is not disturbed by vertical motion and the lift's motion is not disturbed by Pandu's motion. So you will see the x component only has Pandu's motion and the y component only has the lift's motion. So if the Pandu has moved this much, that much I cap is the displacement in the x-axis, and if the lift has gone up by so much, so this is the displacement in the y direction. So x displacement plus y displacement gives you the resultant position of that particle. I hope this is clear. All right, Kirito, no problem. I hope now you are able to visualize. So don't worry, I am here to make you guys visualize in a very simple manner. All right. Now, Now, let's take some special cases and see. So let's say you have to add these crazy equations out here, something I cap, something j cap. Now you'll be scratching your head just like you did sometime back when I asked you to add two SHMs in 1D. But there is a simple way of doing that, and let me show you how you can add something I cap plus something j cap. Okay, so what is, but you can't combine it into one term, guys. Let me warn you in advance. The reason why you can't convert it into one term is because this is I cap and this is j cap. I does not affect j, j does not affect I. But the resultant motion can be perceived, and you have only simple cases in this, and let's see what those simple cases are. Let's see what those simple cases are, guys. Come on, pay attention. Let's say the phase difference between them is 0 degrees. So both these motions perpendicular to each other have no phase difference. So that means motion of Pandu will be AP, or I will just put it as X is nothing but A1, okay, sine omega t, and Y will be nothing but A2 sine omega t, but there is no phi because phase difference is assumed to be 0. Okay, very, very important. Now, what will the resultant motion look like? Very simple. Just divide both of them, guys. This is the y coordinate, right? This is the x coordinate. 1 second. This was x, this is y. So just divide both of them. Just divide both of them. What will happen? Y divided by x will be A2 by A1. Sine by sine goes off. So what will you get? Y is A2 divided by A1 into x. Now what is this equation, guys? This is nothing but the equation of a straight line. This is the equation of a straight line, and the slope is, what is the slope? The slope is A2 by A1. That means the motion of Pandu will be like this, like this, like this, like this. He'll keep going like this. That's it. That's the equation of motion. That's all. As simple as that. Next situation, del phi, okay, del phi is 180 degrees or pi radians. One and the same thing, guys. Del phi is 180 degrees or pi radians. Let's see what happens in this situation. So x is A1 sine omega t, but y is A2 sine omega t plus pi. Now we know sine theta plus pi is minus sine theta, so it will become minus A2 sine omega t. So that is nothing but y. Now just divide both of them, guys. See what will happen. So y divided by x will be how much? It will be minus A2 by A1, and therefore you will get y is equal to minus A2 by A1 into x. Now what is this again? This is also a straight line, but this time the slope, guys, is negative A2 by A1. So the second time, so understand, this was when del phi was 0, but when del phi is 180 degrees, the slope is negative, so Pandu's motion will look like this. It will keep on going like this. So this is when del phi is 180 degrees. Did you understand this, guys? I hope this makes sense. Yeah. So Pandu will be going not only right but also going up. Again, Pandu will be coming back. I'll show you this in the simulation. You will visualize it even better. Don't worry. Hold on. I'm going to show you a very cool simulation in a bit. Hold on for that. But are these the only two cases? Obviously not. There are some more cases and I'll just show it to you. Hold on. Now I'll take one more special case. Let's say del phi is nothing but 90 degrees. So x will be sine, okay, 1 second. Let's say del phi is 90 degrees. So x will be A1 sine omega t, and y is nothing but A2 sine, alright, omega t plus pi by 2 because it's 90 degrees. Therefore, y will become A2 sine of theta plus 90, guys. It's in the second quadrant. Its sine is positive and it will become cos because there is pi by 2 over here. So it will become cos omega t. Now, here is the simple trick that I'm going to use. Guys, from the first part, think about what is sine omega t. Sine omega t is nothing but x by a1. And from the second part, look at what cos omega t is equal to. Cos omega t is nothing but y by a2. So guys, what if I square them and add them? What will I get? It will be 1. So sine square omega t plus cos square omega t will be x square by a1 square plus y square by a2 square. But I know LHS is going to be 1, right? LHS is going to be 1. So this will be nothing but 1 is equal to x square by a1 square plus y square by a2 square. Now this is a very special equation. If you're in 11th, most likely you would not have read much about this, but I'll tell you that this is the equation of ellipse, and you will learn this in 12th, and don't worry about it. So this is the equation of ellipse. It's like that oval. Oops. It's nothing but ovalish shape. So this is x and y axis, guys. The ellipse looks something like this. This is your A1 and this is your A2. This is how it looks like. And a special case. You know what is a special case? When A1 is equal to A2, then it implies that it will be a circle. Because think about it, if the ovals this diameter and this diameter are same, it will nothing but be a circle. I hope this is clear. Yes. Ask me, making me jealous. Don't worry, eat, yeah. Everybody has its own day, no problem. Eat, eat, eat. I'll be in fact happy if you eat chocolates. Alright. I hope this is clear. Okay, so understand this also works for 270 degrees. Yes, it even works for 270 degrees, guys. You can try it out. Just that you might get a minus sign somewhere, but when you square it, that minus sign will go off, so don't have to worry about it so much. Yes, Sunil, 2023 will also come on this channel starting from March or April. Don't worry, stay tuned. Yes, very good, very good. Okay, now you'll be like, sir, what if del phi is something else? That equation is not there in our syllabus. Something else means apart from 0, 90, 270, etc. That equation is not there, but you should remember the shape. You know what is the shape? The shape is nothing but still an ellipse, but this is a rotated ellipse. This is nothing but a rotated ellipse. Guys, and I'm now going to show you the simple simulation, and you will see when I change the phase difference, how this diagram gets converted from straight line to ellipse to circle. Are you guys now ready? So it's just rotated ellipse, or you basically rotate the axis, that's it. So for any other angle, it's always an ellipse, or it could be a circle if you know the amplitudes are same, but it will be a rotated diagram, that's all. So these are the only possibilities: ellipse, straight line, circle, rotated ellipse. This is a rotated ellipse, this is a normal ellipse, this is a straight line. Okay, so are you guys now ready to see the simple simulation? All right, so don't worry, I'm going to show it to you, but before that, answer this simple quiz and I'll show you this very amazing simulation. Come on, read this out. Two linear simple harmonic motions of equal amplitudes and frequency are impressed on a particle along x and y axis respectively. The initial phase difference between them is pi by 2. What is the resultant path followed by the particle? Come on, what is the resultant path followed by that particle? Come on guys, come on, quickly answer and then I'll show you the simulation. Very easy. Come on, you can do this, very easy. Is it A, B, C, D? Most of you are saying A, only Aishwarya says B. Alright, come on, ellipse. Come on guys, think about it again, the answer will be a circle. Very important, read it carefully, equal amplitude. If the amplitudes are equal, will it be an ellipse? No, it will become a circle. So understand the answer is a circle. Be careful, read the question carefully, that's why I tell you. Be careful, yes, understood? Alrighty, yes. So let's get going to the next question and then we'll see the solution. Come on guys. Particle is subjected to two SHMs at the same time in perpendicular directions. That means one in X and one in Y. The amplitude of the first motion is 3 and that of the second motion in Y axis is 4. what is the resultant motion and the amplitude if the phase difference is 180 degrees, guys? Come on. I just told you about it. I just told you about it. How will the motion look like if the del phi is nothing but pi radian? What will happen? One motion is in x and one motion is in y. Come on, the y motion has an amplitude of 4 and the x motion has an amplitude of 3. What will happen to the resultant motion, guys? The resultant motion will be also SHM. It will look like a straight line with a negative slope. Do you remember? I just told you about it. This was when del phi was 180 degrees. So this is nothing but still a straight line. Correct? Yes. So understand what will be the amplitude. This is the amplitude. This is the amplitude, guys. And what will be the amplitude? It's very simple. If this and this is drawn like that, this much will be 3, this much will be 4. So obviously the amplitude must be 5 units. So hence the resultant amplitude is 5 and the motion will be a straight line. As simple as that. Correcto? Very good. So that's how simple these questions are. By the way, these are our stars of last lecture who have solved all the homework questions. Now I'll show you the simulation. Hold on. Very good Khushbuja, very good Yalini Selva, and very good Elakia. Very good, very good. All these people have answered our homework questions, and those of you who will answer these questions next time, I'll be showing their names in our live sessions, guys. So these are your homework questions. This is homework question 1, 2 and 3. So these are your 3 homework questions. All right. No, you don't have to multiply by 2. I think the radius was asked. Amplitude will be only on one side, Kirito, not the entire thing, only one side. Okay. Cool, cool, cool. Oh, Saurav, you have answered from your sister's account, I guess. No problem. Okay. So this is back to Desmos. This is back to Desmos out here. And let's see what we can do. So guys, this is y is equal to, let's say I write an equation like 3 sine. I don't know, maybe 1 second, y1 I'll write. So this is y1 is equal to 3 sine 4 pi x. So this is my x-axis. You can see this is the graph of a sine curve, as simple as that. I can change this value and you will see the wavelength will also change accordingly. So I can make it like pi by 3 and stuff like that. This is what you will get. Okay, so this is normal sine graph. So let me again copy paste this. Okay, and let me put another graph, but this graph I will call it as y2, but I will add some phase. So I'll put plus p. That p stands for phase difference, guys. Okay, that p stands for phase difference. So you can see that I can change the value of p, and let's keep it from 0 to pi. Okay, and the steps of 0.05 pi. Okay. Okay. Now observe this. Look at this. The blue and the red curve are aligned together when p value is 0. That is, the phase difference between them is 0, guys. Okay, I can keep them at different amplitudes so that you can see that very easily. So blue one is having amplitude 2, or you can even make this amplitude 2 and you can make this amplitude 3. It doesn't matter, guys. The phase difference between them is 0. You can see that they are in phase. There is no phase difference right now. There is no phase difference. Okay. Now think about it. If I change the phase difference, let's see what will happen. Look at that, how the two graphs change their alignment, and when I make it as pi, you will see that, you know, that blue wave or that blue graph has exactly shifted by pi radians, or exactly half a wave, because pi radians is this much, this is more pi radians. Totally one oscillation is 2 pi radians, remember that. So that's why they have shifted by exactly, one crest or one trough. You can see that. Okay, So Raghunesh, why don't you comment after the lecture? It's difficult for me to answer when a live session is going on, all these kind of queries. So please understand, comment after the video is over. Okay. Now, what if I add both of them and let's see what happens. So y is y1 plus y2. Yes, Jiva, it is useful for you too. Physics won't change. Understand that? So what if I do that? And hold on 1 second. Let me choose a different color, the green color. So these blue and red are the individual waves. Look at the resultant wave, guys, the green one. Can you see it's perfect addition? Perfect addition. And what if I change the phase difference between them? If I change the phase difference between them, look at that, the amplitude of the resultant became so small. The red is 2, the blue is 3, the resultant is only 1 because the phase difference between them is pi radians. Can you see that? Can you see that, guys? I hope everybody saw this. And you can see this is the least amplitude of the green resultant wave, and anything different will change the amplitude, and this is the maximum amplitude. So the amplitude can change from maximum to minimum when you change the phase difference between them. I hope this is clear. I hope this is clear. Now, the last thing that I want to show you today. Okay, so the last thing, guys, I hope this was very, very clear and very useful for all of you. You can also play with Desmos later on. So, x is 3, I don't know, sine, I don't know, something 0.5t, okay, and y, okay, y is nothing but, I don't know, maybe 4 sine 0.5t, okay. Now, let's say these are our two equations. I should have got the slider. 1 second, guys, 1 second. X is equal to 3 sine 0.5t, okay. Okay, I'm not sure why I didn't get the slider. I'll just refresh the screen. Okay, so x is equal to 0.3 sine 0.5t. I'll choose some other variable. Oops, I'm not sure why it's not coming. Okay. Okay, now it's come. Just 1 second, guys. It's very weird. Okay, sometimes it gives some problems. Okay, let's add the slider. By the time it is there, okay, glad it is here. Okay. Now, okay, let's change the value from 0 to 10, or maybe something like 4, and let's increase it in the steps of 0.05. Okay, so let's see how this works. I don't know whether you can see this point going slightly towards the right, and it will again come back. So we can make it like 10 or something, or maybe 4 pi. Let's see. See this, guys, how it goes back and forth. See how it is going back and forth. It is performing SHM. Can you see that red line? Yes, can you see that red line, guys? Can you see that red line, guys, going back and forth? Yes, everyone? Oh, is it strange type of sounds? I'm not sure why you're getting strange type of sounds. Okay, great. Now, let me add y is equal to 4 sine, and there is 0.5t. Okay, now observe. Okay, now observe, guys, this one is, let's say, blue. Okay, and now observe the resultant. Observe how their intersection moves. Observe how their intersection moves. Is it not moving in a straight line? Observe that. And why is it moving in a straight line? Because there is no phase difference between them. There is no phase difference between them. I hope this is clear. Yes. Now let's add a phase difference. So let's add pi radians over here and see guys how the slope has changed. Look at the resultant motion guys. Look at the resultant motion, how it looks like. Do you see that negative slope? Do you see that negative slope? Alright. Now let's make it pi by 2 and see what happens. See how it goes. See how it goes. Is it going in an elliptical form? Look at that. So there are two SHMs superimposed over each other. See how that resultant motion is. Okay, and let's make it a circle by making their amplitude same. Let's make their amplitude same. Now it will be a circle. Observe that. It is a circle now. Can you see that? It's a proper circle. And if you make this phase difference something else like pi by 3 or something and keep something else. Okay. Now you will see this is a rotated ellipse. I hope you can see that. It's a rotated ellipse. This is how it is looking like. I hope this is very, very clear. Very interesting simulations. Very interesting simulations. I hope you have enjoyed these simulations, and I also hope that you have already enrolled or at least filled the forms for the Eklavya batch, which is going to start very soon. It's free of cost with lots of assignments, questions, full syllabus test series, special sessions by AP Sir, Pulkit Sir, and post-advanced mentoring. And these are meant for all the students who are right now in 12th or dropping a year. So basically going to attempt the coming 2021 JEE Advanced examination. Last year, All India rank 41, 43 and more than 550 selections in advanced from Vedantu came from this batch. So guys, you can see the changes. Go ahead, check out all the details. Everything is mentioned in the session PDF. These are all the ranks which are mentioned. Go check it out. You'll also feel confident and you'll also feel thrilled to join this Eklavya program. The entrance tests are on January 7th and January 10th. So do not miss these dates. Please fill up this form and also join the Telegram group for getting more updates about the Eklavya program and any other things related to JEE, NCERT, boards, etc. Thank you guys very much. I hope you had a great time. Do not forget to hit the like button and the subscribe button if you have not done it yet. And come again tomorrow at the same time, 7 o'clock, we are going to talk about damped oscillations and forced oscillation. There are some really wonderful things that I'm going to show you tomorrow as well. Bye bye. Take care. This was your boss, Captain Thalai Baba, whatever you want to call me, Shreyas Sir, your master teacher and the anchor for this channel as well. Stay safe guys. Keep coming. Keep learning. Tada.